Along this lecture, we'll find out the area of a circle using two different methods. In the drawing, we have a circle. We have also square ABCD. This is line segment AP, is equals to 1 unit in its length. This is line segment QC, that is equals to 4. Again, our mission is to find out the area of this circle. So we start with the first method. First of all, we know that ABCD is a square, and therefore all those four angles are right angles. So here, this is a right angle. This is also a right angle. This is a right angle. And this is also a right angle. In the next step, we define the center of this circle. This point is point O. And we define the point of tendency of this tangent AB with this circle. This point is point S. And we join points O and S together by a straight line. Point O is the center of the circle, point S is the point of the circle itself, therefore OS is the radius of this circle. We define the radius of this circle as x, so OS equals to x. So here we can implement all one. Repeat quickly all one. According to rule 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So in the drawing, we have a circle, and this is tangent AB, that is tangent to this circle, and this point M. In addition, we have the radius OM, that is equals to R. The radius OM is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to this rule, rule 1. So we can actually implement rule 1 in our drawing. In our drawing, we have the radius OS, that is equal to x. The radius OS is drawn to point S, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius SO. If AB is perpendicular to SO, it means that this angle equals to 90 degrees. And this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and Q together by a straight line. OQ is of course the radius of this circle, that is equals to x. The radius of Q is drawn to point Q, that is the point of tendency of tangent BC with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees. And this angle also equals to 90 degrees according to the same rule, rule 1. So by doing this construction, you get it here, quadrilateral SOQB. Inside this quadrilateral SOQB, we have 1, 2, 3 rectangles. The sum of 3 rectangles is 270 degrees, so 270 degrees plus the size of this fourth missing angle. In total, they must be equal to 360 degrees according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees, and therefore this fourth missing angle must be equal to 90 degrees in its size. So inside quadrilateral SOQB, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be trisomorphic diagonal not a square. So we relate to this quadrangle SOQB is a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So a rectangle SOQB, side SO must be equal to the opposite side QB. But SO is x, therefore QB must be also equal to x units in its length. Likewise, according to the same rule, in the same rectangle SOQB, side OQ must be equal to the opposite side SB. But OQ is x, therefore SB must be also equal to x units in its length. So if we found out that quadrangle SOQB is not a rectangle but a square, why? Because of the fact that all of its sides are equal to each other, each side of this square SOQB is equal to x units in its length. We know that all the sides of square ABCD are equal to each other. That is to say, side AB equals to side BC equals to side CD equals to side DA. And especially side AB equals to side BC. So I write it down. In square ABCD, side AB equals to side BC. AB in total equals to AS plus SB. AB equals to AS plus SB, and AB equals to BC. BC in total equals to BQ plus QC. BC equals to BQ plus QC. So according to equation 1, we have found out that AS plus SB equals to BQ plus QC. AS is the missing side, so we leave it as it is, plus SB. SB equals to X, and it is equal to BQ. BQ also equals to X plus QC. QC is 3. So in total, according to equation 1, we have found out that AS plus X equals to X plus 3. Here we subtract X from this equation 1, so X will get cancelled. And we left only with AS that is equal to 3 units in its length. AS equals to 3 units in its length. So actually this is by 7 AS that is equal to 3 units in its length. In the next step, we'll do a construction. That is to say, from this point P, we will go perpendicular on the radius SO. Again, from point P, we will go perpendicular on the radius SO. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We will define the touching point of the perpendicular from point P and side SO. This point is point N. So actually, when doing this construction, we're going to do quadrangle AP and S. So inside the small quadrangle AP and S, we have 1, 2, 3 rectangles. The sum of 3 rectangles is 270 degrees. So 270 degrees plus the size of this 4 facing angle, in total they must be equal to 360 degrees, according to the rule that states that the sum of the angles in any quadrangle is equal to 360 degrees, and therefore this 4 facing angle must be equal to 90 degrees in its size. So actually, inside the small quadrangle inside the small quadrangle AP and S, we have 4 right angles, and according to rule 5, any quadrangle that has 4 right angles must be this rectangle plus a square. So we relate to this small quadrangle AP and S as a rectangle because it has 4 right angles. So I can know So this is polynomial A, P, and S. That is a rectangle according to rule 5. But we also know that the opposite sides of a rectangle are equal to each other. So in the small rectangle AP and S, side AP must be equal to the opposite side NS. But AP is 1, therefore NS must be also equal to 1 unit in its length. Likewise, according to the sum rule, in the same small rectangle AP and S, side AS must be equal to the opposite side NP. But AS is 3, therefore NP must be also equal to 3 units in its length. What is the length of the missing 97, 97, and O? From the drawing, it is very easy to see that NO in total equals to SO minus SN. Again, NO equals to SO minus SN. So, write it down. NO equals to SO minus SN. So, NO equals to SO. SO is the radius of this circle that is equal to X minus SN. SN equals to 1. So in total, NO equals to X minus 1 unit in its length. This is 97 NO that is equal to X minus 1 units in its length. In the next step, we join points P and O together by a straight line. PO is of course the radius of this circle that is equal to X. So in the next step, I'll copy this right triangle P and O in a new page and we implement the Pythagoras theorem on this right triangle P and O. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here by PT is the progression for Pythagoras theorem. So actually, this is the great right triangle P and O that occurs from the original drawing. According to the Pythagoras theorem, it is right triangle P and O, PO squared, that is the square of the hypotenuse, equals to PN squared plus NO squared. So I write it down. So PO squared, that is the square of the hypotenuse, is equal to PN squared plus NO squared. PO is X, therefore PO squared is X squared, and it is equal to PN squared. PN is 3, therefore PN squared is 3 squared, that is 9, plus NO squared. NO is X minus 1, therefore NO squared is X minus 1 squared. So in total, we found out that X squared equals to 9 plus X minus 1 squared. So X squared equals to 9 plus X minus 1 squared. X minus 1 squared equals to X squared. plus 1 squared, that is 1, minus 2 times x times 1, that is minus 2x. So here we have x squared on both sides of the equation, so x squared will get cancelled. After we cancelled x squared, on this side of the equation we left with nothing, that is to say 0. On the other side of the equation we left with 9 plus 1, that is 10, minus 2x. So in total we found out that 0 equals to 10 minus 2x. So here we add 2x to this equation, and we get that 2x equals to 10. So here we divide this equation by 2, and finally we get that x equals to 10 over 2, that is 5. So if we found out that the radius x of this circle is equal to 5 units. Our mission is to find out the area of this circle. Actually, the area of any circle is equal to pi times the radius of the circle squared. Repeat again, the area of any circle equals to pi times the radius of the circle squared. And therefore, the area of our circle must be equal to pi times the radius of our circle squared. The radius of our circle is x, therefore the radius squared is x squared. So in total, the area of our circle must be equal to pi x squared. So it is pi times x squared. X is 5, therefore x squared is 5 squared. So in total, the area of our circle must be equal to pi times 5 squared. 5 squared is 25, so in total this expression equals to 25 pi. 25 pi is 78.54 square units. So we actually found out that the area that we are looking for this question, that is the area of this circle, equals to either 25 pi square units, so in terms of numbers, the area of this circle equals to 78.54 square units. So we finished with the first method. In the next step, I present to you how to find out the area of the circle according to the second method. So first of all, we know that ABCD is a square, and therefore all those 4 angles are right angles. This is a right angle. This is also a right angle. This is a right angle. And finally, this is also a right angle. In the next step, we will define the center of this circle. This point is point O. We will define the point of tendency of this tangent AB with this circle. This point is point S. And we will focus on this common external point B. From this common external point B, we have 2 tangents to this circle, tangent BS and tangent BQ. According to rule 2, they are equal to each other. This is to say BS equals to BQ. So, application of rule 2. According to rule 2, the lengths of 2 tangents from a common external point to a circle are equal. So, in the drawing, we have a circle, and this is the common external point P. From this common external point P, we have 2 tangents to this circle. Tangent PA and tangent PB. And according to this rule 2, they are equal to each other. That is to say, PA equals to PB. So we can actually implement rule 2 in our drawing. As I already mentioned before, from this common external point B, we have 2 tangents to this circle, tangent BS and then tangent BQ. And according to rule 2, they are equal to each other. That is to say, BS equals to BQ according to rule 2. So I already know BS equals to BQ according to rule 2. So actually, if we define the length of this tangent BS as x, then the length of this tangent BQ must be also equal to x because they are equal to each other according to rule 2. We know that all the sides of square ABCD are equal to each other. That is to say, side AB equals to side BC equals to side CD equals to side DA. And especially side AB equals to side BC. So, we'll let it know. In square ABCD, side AB equals to side BC. Side AB equals to AS plus SB. AB equals to AS plus SB. And AB equals to BC. Side BC equals to BQ plus QC. BC equals to BQ plus QC. AS is the missing side, so we leave it as it is. Plus SB, SB is X, and it is equal to BQ, BQ is also X, plus QC, QC equals to 4 units in itself, according to what is given as the question. So in total, according to equation 1, we have to find out that AS plus X equals to X plus 3. Here we subtract X from this equation 1, so X will get cancelled. And we left only with AS that is equal to 3 units in its length. So actually found out that the length of the missing 970 AS is equal to 3 units. This is 970 AS that is equal to 3 units in its length. In the next step, we will extend side AD of this square ABCD by a straight line until it touches the circle. And we define the touching point of the extended side AD with the circle. This point is point M. In the next step, we focus on this common example point A. On this common example point A, we have tangent AS, that is tangent to this circle at point S, this point. And if we draw this straight line from the same common example point A, it will cut the circle at 2 points, point P and point M. Therefore, we have here chord PM. And therefore we can implement here rule 10. According to rule 10 is true in any circle. In any circle, if AB is any chord in the circle, AB is a chord inside the circle, and PT is a tangent to the circle. PT is a tangent to the circle at point T. So in this moment, the following equation is true, that PT square equals to PA times PB. Again, PT square equals to PA times PB. So we can definitely implement rule 10 in our drawing. Because in our drawing, if we focus on this common sum point A, from this common sum point A, we have here tangent AS, and from the same common sum point A, we have chord PM. So all the requirements of rule 10 are satisfied, and therefore we can implement rule 10. According to rule 10, the following equation is true, that AS square equals to AP times AM. Again, AS square equals to AP times AM. So I will write it down. So if we focus on the common sum point A, according to rule 10, the following equation is true. That AS square equals to AP times AM. AS is 3, therefore AS squared is 3 squared, that is 9, and it is equal to AP. AP is 1 times AM. AM in total equals to AP plus PM. Again, AM in total equals to AP plus PM. AM equals to AP plus PM. So total 9 equals to 1 times AP. AP is 1 plus PM. So here you can ignore this equation, because anything that is multiplied by 1 will not change the value of this. If it's will not change the value of the expression, so we can ignore 1 in this equation, and we get that 9 equals to 1 plus PM. Here we subtract 1 from this equation, and we get that PM and get that PM equals to 9 minus 1, that is 8. So if we found out that the length of this chord called PM is equal to 8 units. In the next step, we will do a construction. That is to say, from this point O, that is the center of this circle, we will do perpendicular on chord PM. Again, from point O, that is the center of this circle, we will do perpendicular on chord PM. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and this chord PM. This point is point N. So actually, from the center of this circle, that is to say from point O, we go perpendicular ON on chord PM. Again, from the center of the circle, that is point O, we go perpendicular ON on chord PM. Therefore, we can implement here rule 11. So I'm clicking on rule 11. According to rule 11, the perpendicular to a chord one from the center of the circle bisect the chord. So in the drawing, we have a circle, and point O is the center of the circle, AB is the chord inside the circle, and from point O, that is the center of the circle, we do perpendicular OM on chord AB. Again, from the center of this circle, that is to say from point O, we do perpendicular OM on chord AB. So here, this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. And according to this rule 11, whenever you draw perpendicular from the center of the circle towards any chord, it will bisect the chord. That is to say, perpendicular OM, that is one from point O, that is the center of the circle, will bisect chord AB. That is to say, perpendicular OM divides chord AB into two halves. Each half equals to AB over 2. So the first half AM equals to AB over 2, and the second half MB also equals to MB over 2. So AM, the first half AM equals to the second half MB, and each half equals to AB over 2. So AM equals to MB equals to AB over 2. We can definitely implement rule 11 in our drawing. Why? Because in our drawing, from the center of the circle, that is to say from point O, we do perpendicular ON on chord PM. Again, from the center of the circle, that is to say point O, we do perpendicular on chord PM. And therefore, all the requirements of rule 11 are satisfied, and therefore we can implement rule 11. According to rule 11, perpendicular ON bisect chord PM. That is to say, perpendicular ON divides cos PM into 2 halves. Each half equals to PM over 2. So the first half is Pn, and it is equal to the second half, that is Nm, and each half equals to Pm over 2. So, repeat again, perpendicular ON, that is one from point O, that is the center of the circle, will bisect 4 Pm. So the first half is Pn. The first half, of course, equals to the second half, that is Nm, and each half equals to Pm over 2. And again, according to rule 11, perpendicular ON bisect 4 Pm. So the first half is Pn, and it is equals to the second half, that is Nm, and each half equals to Pm over 2. Pm is 8, therefore Pm over 2 is 8 over 2, that is 4. From this long equation, we derive that Pn equals to 4. Pn equals to 4 units in itself. This is to say the length of this 97 Pn is 4 units. So in the next step, we join points O and S together by straight line. Point O in the center of the circle, point S is the point of the circle itself, therefore OS is the radius of this circle. Write it down, OS is the radius of this circle. And because of the fact that the radius OS is drawn to point S, that is the point of tendency of tangent AB, if this circle, and whenever your radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius SO. If AB is perpendicular to SO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees, according to rule 1. So by doing this construction, we better do quadrilateral AN OS. Inside this quadrilateral AN OS, we have 1, 2, 3 angles. The sum of 3 angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees, according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees, and therefore this fourth missing angle must be equal to 90 degrees in its size. So inside quadrilateral AN OS we have 4 angles. And according to rule 5, any quadrilateral that has 4 angles must be this rectangle if not a square. So we relate to quadrilateral AN OS as a rectangle because it has 4 angles. So I want it down. This is quadrilateral AN OS, that is a rectangle according to rule 5. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle AN OS, side AN must be equal to the opposite side OS. But AN in total equals to 1 plus 4, that is 5, therefore OS must be also equal to 5 units in its length. But OS is the radius of the circle, and therefore the radius of the circle equals to 5 units in its length. Repeat again, the radius of this circle is equal to 5 units in its length. Our mission is to find out the area of this circle. Actually, the area of any circle is equal to pi times the radius of the circle squared. Repeat again, the area of any circle equals to pi times the radius of the circle squared, and therefore the area of our circle must be equal to pi times the radius of our circle squared. The radius of our circle is 5, and therefore the radius squared is 5 squared. So in total, the area of our circle must be equal to pi times 5 squared. 5 squared is 25, so in total this expression equals to 25 pi. 25 pi is 78.54 square units. So actually, in both methods, we found out that that we're looking for this question, that the area of this circle, it is equal to either 25 pi square units, so in terms of numbers, the area of this circle equals to 78.54 square units. So in the next step, I'll summarize the lecture. We'll start with the first method, of course. So our mission in this question is to find out the area of this circle, and we actually found out the area of this circle in two different methods. So in the first method, first of all, in the domain we have a circle, and this is square ABCD. You know that this is 978 feet, that is equal to 1 unit in its length. This is 978 QC, that is equal to 4 units in its length. Again, our mission is to find out the area of this circle. So first of all, we know that all the sides of this square ABCD are right angles. All the angles inside this square ABCD are right angles. So those four angles, they are all right angles. And we define the center of this circle, this point is point O, and we define the point of tendency of tangent AB with this circle, this point is point S. In the next step, we join points O and S together by straight line. OS is the radius of this circle, we define the radius of this circle as X. The radius OS is drawn to point S, that is the point of tendency of tangent AB with this circle. And whenever a radius is drawn to the point of tendency, then tangent AB will be perpendicular to the radius SO. If AB is perpendicular to SO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and Q together by straight line. OQ is the radius of the circle, that is equal to X. The radius OQ is drawn to point Q, that is the point of tendency of tangent BC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule 1. By doing these constructions, we can delay quadrangle SOQB. Inside this quadrangle SOQB, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this 4 pieces again, in total, they must be equal to 360 degrees according to the rule that says that the sum of the angles in any quadrangle is equal to 360 degrees. And therefore, this 4 pieces again must be equal to 90 degrees in its size. So inside quadrangle SOQB, inside this quadrangle, we have 4 right angles, and according to rule 5, any quadrangle that has 4 right angles must be this rectangle, if not a square. So we relate to this quadrangle SOQB as a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So a rectangle SOQB, side SO must be equal to the opposite side QB. But SO is X, therefore QB must be also equal to X units in its length. Likewise, according to the same rule, in the same rectangle SOQB, side OQ must be equal to the opposite side SB. But OQ is X, therefore SB must be also equal to X units in its length. So we found out that quadrangle SOQB is not a rectangle but a square. Why? Because of the fact that all of its sides are equal to each other, each side of this square SOQB equals to X units in its length. We know that ABCD is a square, and therefore side AB equals to side BC equals to side CD equals to side DA, and especially side AB equals to side BC in square ABCD. So I repeat again, in square ABCD, side AB equals to side BC. AB is AS plus SB, and BC is BQ plus QC. And again, AB is AS plus SB, and BC is BQ plus QC. So in total, according to equation 1, we have found out that AS plus SB equals to BQ plus QC. AS is the missing side, so we leave it as it is, plus SB. SB equals to X, and it is equals to BQ, that is also X, plus QC. QC is 3. So in total, according to equation 1, I can find that AS plus X equals to X plus 3. Here we substitute X from this equation 1, so X will get cancelled, and we left only with AS, that is equal to 3 units in its name. So actually this is 97 AS, that is equal to 3 units in its name. In the next step we did the construction, that is to say from this point P, we do perpendicular on the radius SO. Again from point P we do perpendicular on the radius SO. So actually this angle equals to 90 degrees and this angle also equals to 90 degrees according to our construction. When you find the touching point of the perpendicular from point P and this side SO, this point is point N. By doing this construction we created the small quadrilateral AP and S. This is the small quadrilateral AP and S. Inside this one quadrilateral AP and S, we have 1, 2, 3 right angles. The sum of 3 right angles is 470 degrees, so 270 degrees plus the size of this 4 facing angle. In total, must be equal to 360 degrees, according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore, this 4 facing angle must be equal to 90 degrees in its side. So inside the small quadrilateral AP and S, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be a rectangle if not a square. So in order to this small quadrilateral AP and S is a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle AP and S, side AP must be equal to the opposite side NS. But AP is 1, therefore NS must be also equal to 1 unit in its name. Likewise, according to the same rule, in the same rectangle AP and S, side AS must be equal to the opposite side PN. But AS is 3, therefore PN must be also equal to 4 units in its length. What is the length of the missing 97 NO? From the following it is very easy to see that NO in total equals to SO minus SN. Again, NO equals to SO minus SN. So NO equals to SO, SO is the radius of the second, it is equal to X, minus SN. N is 1, so in total NO equals to X minus 1 unit in its length. In the next step I call it joint points P and O together by side line. So PO is the radius of this circle that is equal to X. In the next step I copy this right triangle P and O and implemented the Pythagoras theorem on this right triangle P and O. According to the Pythagoras theorem, in any right triangle the score of the product equals to the sum of the scores of the perpendiculars. So actually this is the right triangle P and O that I copied from the original drawing. According to the Pythagoras theorem, in this right triangle P and O, PO squared, that is the score of the hypotenuse, equals to Pn squared plus NO squared. Again, PO squared equals to Pn squared plus NO squared. PO is X, therefore PO squared is X squared, and this is equals to Pn squared. Pn is 3, therefore Pn squared is 3 squared, that is 9, plus NO squared. NO is X plus 1, therefore NO squared is X minus 1 squared. So in total, we can find out that X squared equals to 9 plus X minus 1 squared. So X squared equals to 9 plus X minus 1 squared. X minus 1 squared equals to X squared plus 1 squared, that is 1, minus 2 times X times 1, this is minus 2X. So here we have X squared on both sides of the equation, so X squared will get cancelled. After cancelled X squared, on this side of the equation we left with nothing, that is to say 0. On the other side of the equation we left with 9 plus 1, that is 10, plus 2X. So in total, we actually found out that 0 equals to 10 plus 2x. Here we added 2x to this equation, and finally found out that 2x equals to 10. Here we divided this equation by 2, and finally found out that x equals to 10 over 2, that is 5. So x equals to 5 units in its length. This is to say, the radius of this circle x equals to 5 units in its length. Our mission is to find out the area of this circle. Actually, the area of this circle equals to pi times the radius of the circle squared, and therefore the area of our circle must equal to pi times the radius of our circle squared. The radius of our circle is x, therefore the radius squared is x squared. So in total the area of our circle must be equal to pi x squared. X is 5, therefore x squared is 5 squared. So in total the area of our circle must be equal to pi times 5 squared. 5 squared is 25, so in total the value of this expression is 25 pi. So if we found out that the area of this circle, that is the area that we are looking for this expression, it is equal to either 25 pi square units, so in terms of numbers, the area of this circle equals to 78.54 square units. We finish with the first method. In the next step, I present the video how to find out the area of this circle according to the second method. So, first of all, we know that ABCD is a square, therefore all those four angles inside square ABCD are right angles. And the next step, we define the center of this circle. This point is point O, and we define the point of tendency of tangent AB with this circle. This point is point S. In the next step, we focus on this common sum point B. From this common sum point B, we have two tangents to this circle, tangent BS and tangent BQ. And according to rule 2, they are equal to each other. That is to say, BS equals to BQ. If we define the length of this tangent BS as x, then BQ must be also equal to x because they are equal to each other according to rule 2. We know that all the sides of this square ABCD are equal to each other. That is to say, side AB equals to side BC. And again, in square ABCD, side AB equals to side BC. AB equals to AS plus SB. Again, AB equals to AS plus SB, and BC equals to BQ plus QC. Again, BC equals to BQ plus QC. So in total, according to equation 1, we actually found out that AS plus SB equals to BQ plus QC. AS is the missing side, so we leave it as it is, plus SB. SB equals to X, and it is equal to BQ, that is also X, plus QC. QC is 3. So in total, according to equation 1, we actually found out that AS plus X equals to X plus 3. Here, subtract X from this equation, equation 1, so X will get cancelled, and we have to leave AS, that is equal to 3 in its length. So this is the missing line 7 AS, that is equal to 3 in its length. In the next step, we extended this line 7 AD by straight line until it touches the circle. At this point, we define the touching point of the extended line 7 AD with this circle. This point is point M. So from this common sum point A, we obtain that AS, and if we draw a straight line from the same common sum point A, it will cut the circle into points P and M. This way we get 4 PM. So all the requirements of rule 10 are satisfied, and therefore we can implement rule 10. According to rule 10, AS square equals to AP times AM. Again, AS square equals to AP times AM. So until again, if we focus on the common standpoint point A, according to rule 10, the following equation is true, that AS square equals to AP times AM. AS is 3, therefore A square is 3 squared, that is 9, and this is equal to AP. AP is 1 times AM. AM in total equals to AP plus PM. AP is 1 and AM equals to AP plus PM. So in total 9 equals to AP plus PM. AP is 1 plus PM. So in total 9 equals to 1 plus PM. Here we subtract 1 from this equation, and finally found out that PM equals to 9 minus 1, that is 8. So this is called PM. This is equal to 8 units in itself, according to rule 10. In the next step, we did the construction, that is to say, from this point O, that is the center of the circle, we do perpendicular on chord PM. Again, from point O, that is the center of the circle, we do perpendicular on chord PM. So actually, this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. So actually, all the requirements of rule 11 are satisfied, and therefore we can implement here rule 11. According to rule 11, perpendicular ON that is drawn from the center of the circle bisects chord PM. Again, perpendicular ON that is drawn from the center of the circle, that is to say from point O, bisects chord PM. That is to say, perpendicular ON divides chord PM into two halves. Each half equals to PM over 2. The first half is PM, and it is equal to the second half, that is ANM, and each half equals to PM over 2. Again, according to rule 11, perpendicular ON bisects chord PM into two halves. The first half is PN, and it is equal to the second half, that is NM, and each half equals 2 pm over 2. Pm is 8, therefore pm over 2 is 8 over 2, that is 4. From this long equation, we derive that pm equals to 4. Pm equals to 4. Yeah. This is line 7pn, that is equals to 4 units in its length. In the next step, we join points O and S together by set time. OS is of course the radius of this circle. So the radius OS is drawn to point S, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius SO. If AB is perpendicular to SO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. By doing this construction, we can do it for the diagonal AN OS. Inside this for the diagonal AN OS, we have 1, 2, 3 angles. This angle equals to 90 degrees according to our construction. This angle equals to 90 degrees because ABCD is a square, and this angle equals to 90 degrees according to rule 1. So in total, inside for the diagonal AN OS, we have 3 angles. The sum of 3 angles is 270 degrees, so 270 degrees plus the slice of this 4 pieces angle. In total, they must be equal to 360 degrees according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore, this 4 pieces angle must be equal to 90 degrees inside. So inside quadrilateral AN OS, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be this right angle, it's not a square. So we will never do this quadrilateral AN OS as a right angle because it has 4 right angles. But we also know that the opposite sides of a right angle are equal to each other. So in right angle AN OS, side AN must be equal to the opposite side OS. But AN in total equals to 1 plus 4, that is 5, therefore OS must be also equal to 5 units in its length. But OS is the radius of the circle, therefore the radius of this circle equals to 5 units in its length. Our mission is to find out the area of this circle. Actually, the area of any circle equals to pi times the radius of the circle squared, and therefore the area of our circle must be equal to pi times the radius of our circle squared. The radius of our circle is 5, and therefore the radius squared is 5 squared. So in total, the area of our circle must be equal to pi times 5 squared. 5 squared is 25, and therefore in total the rule of this expression is 25 pi. So in both methods, we found out that there are the theoretical for this expression, that is the area of this circle is equal to either 25 pi square units, so in terms of numbers, the area of this circle equals to 78.54 square units. Okay, thank you very much.